Hi everyone, welcome. My name's Andy Viduka. I'm here today to talk about the GIRT Scientific Divers Citizen Science Program and how it's a conservation program which will give us information that can inform climate change potentially. Before I go into that today, I'd just like to thank Claire Lancaster for inviting me. Very nice of her to do that. And I would like to apologise to everyone who might have seen the recent Climate Change and Maritime Heritage Conference, because these slides will be very similar. As a little ad to start with, the Ocean Decade of Science, we have a group called the Ocean Decade Heritage Network. We're trying to create a portal where we're gathering information, what people are doing in relation to the marine environment through this period of the next 10 years from 2021 to 2030. If you have programs that you're going to be doing over that time, please share it with the Ocean Decade Heritage Network. Now I'll just get into the conference. So we all understand what is happening in our coastal margin. We're seeing evidence of much higher erosions. We're seeing larger weather events. We're all being visibly aware of this. However, we're less so aware of what's happening in the marine environment. In this instance, I'm showing you an ABC News article from last week, where just down the south coast of Australia, there was identified a heat wave in the water. So we know from monitoring systems that are deployed in the marine environment that the ocean is heating up in certain areas, and we know that's an indicator of climate change. But we also know that there's a large number of shipwrecks that are in that area that can be used as coupons, which we can study to see how we can translate the effects of what's happening in the marine environment to what's happening to our underwater cultural heritage. Why are we doing this? Where's this coming from? Well, one of the pathways to where it's coming from is in 2001, the UNESCO Convention came through, and we understood that the priority was for in situ preservation of heritage. However, to do in situ preservation of heritage, you have to know a few things. You have to know where sites are, you have to know what conditioning, you have to actually be monitoring them regularly in a longitudinal manner to actually note if there's change or issues that you need to mitigate. In Australia and New Zealand, we've got about 10,000 shipwrecks around our coastline. These two coastlines are massive. They're in the top 10 of the global exclusive economic zone, so massive volumes of water with shipwrecks distributed around there. So we've got a problem. We've got this obligation to go and look after sites in situ. But on the other hand, we have a problem where they're so spread and we have so few people, we don't have the resources. We also have an Underwater Cultural Heritage Act that actually protects these sites, whether they're located or unlocated. And that act has objectives in that act, which is to include the public in how we're going to actually look after and manage sites. So that's a very good aspect of the act. Another component is that we know that we need thorough, consistent documentation to be able to say this apple and this apple have changed. Right now, we're comparing all these other factors. So there's not a systematic process that's being approached in the underwater cultural heritage environment at the community level to understand change, and therefore it's not extrapolatable to understand basic change on a given site, let alone climate change impacts. So we have a problem. We needed to understand the condition of shipwrecks. We have to know what's going on, and we have to observe that over a long period of time in a very structured, systematic manner. So around 2017, I was thinking about this quite actively, and I decided that the best way that we're going to actually achieve this in the Australia and New Zealand context was to engage the public through citizen science and to ask that question. And so fundamentally, I did a PhD at that time where I was positing that question with the thesis, public archaeology can inform citizen science, can inform underwater cultural heritage management. So that's the basis for where this presentation today is. The gathering information by Recreational and Technical Scientific Divers, or GIRT as it's called, that's really there to actually be the mechanism to monitor in a systematic manner in the marine environment by the community with training. We know why we need regular systematic monitoring. I just talked about it. But the other thing too is, what do we do with it when we've got that information? It's the why. Why are we doing it? It's not just important for us to know there's change, but for that information to be publicly available so the public become informed about these changing environmental issues, and more importantly, so that managers of heritage actually have science-based information on which they can then say, we need to do something here because this is significant, socially, scientifically, technically, whatever reason. We know that that's what they need to do. So we had to come up with a system that's going to give people information to say why. And the reality is then this citizen science project, like many citizen science projects, is effectively a canary in the coal mine, using that yin there for people. So in the days where people used to take down a canary in the coal mine, the canary would actually die if gas was leaking out of the coal mine, and the miners could potentially run away and save themselves. The reality is that what we're doing here within any citizen science, which is looking at macro changes in the marine environment, we're using that to get trend observations of what's going on, which can inform decisions. So that's where we are here. We're in the trend observation world with good, robust data that can inform people to say, there is a problem there, we need to do further investigation, or actually we need to do rescue archaeology, or we did anything else along that side. GIRT actually was designed around what the open water diver would be qualified, what a diver would have on their kit, plus the acquisition of some scales, a slate, and an underwater camera. And after that, it's a lot of post-processing stuff using a computer. So GIRT is very much a fairly low entry point cost program, but there is a cost. But most divers have many of these facets and can easily get a 30-metre take from the local shop. GIRT is set up on 5 survey sheets. I'll just go through them. There's guidelines for the GIRT process. They're available online, so anyone can easily access those, download those, read those. You don't have to be a member. It's out there. It's been out there since about 2017, 2018, so you're welcome to actually read that. It is an iterative document. I keep developing and changing it as I keep tweaking things. So please look at that document. And then there are 5 survey sheets. I call it a surface sheet, mud map or site sketch in the UK, underwater data sheet, photo condition sheet, and then a video and photogrammetry sheet. Across these sheets, there are 59 unique fields of data, and those fields of data can be populated by the divers in maybe 2-3 dives on a given site. They can get most of the data for that. There's also, and I'll draw your attention to step 5 in the process, it says environmental survey. This is a bolt-on process within the GIRT program. And so what happens there is GIRT actually recognises that we need to look at sites to understand what's happening on the condition of the site, what's happening to the environment around the site. We need to actually look both at the cultural impacts, the change in environment, physical deterioration, as well as what's happening to the marine environment, the sessile marine vertebrates attached to the wreck, as well as the pelagics and other marine life around the wreck. So we need to couple this GIRT process with a marine science, citizen science program, and we'll share data. So that's what we'll do in the GIRT process. GIRT effectively uses about 30% of what a very thorough conservation science survey of the site would do. But to give you an example, there's been about 112 full conservation surveys in Australia conducted by the West Australian Museum since the 1970s. So 112. Now, that's not a lot of data when you've got 7,500 sites and you need to actually use that information to make broad decisions around the heritage assemblage underwater. It's good for the site, but it's only a one-off and often is just literally a baseline data set that's never been repeated. So what do we need? We needed to bring that level of data down to what was achievable by an individual and what could be repeatable in a systematic manner in a regular way. So to achieve this and to facilitate this project, I actually created a bespoke website with SRA IT technology. And with that, it allows me to run and administer the whole of the GIRT program. In this instance, members can go online, they can adopt a site if they can see that it's available through what's been preloaded into the website. If it's not preloaded in the website, they can give me some basic information and I can create a dot on the map anywhere in the world for them. They can then adopt that site, and then with that information, you can actually see the name of the person who's adopted the site, an image of the site, and actually get the opportunity to access the site records, to see the report for the site. Members, once they've adopted the site, can then undertake their surveys. They've got the information there, the survey reports, Once they've collected the data, they can then save the data and then enter the data through the survey reporting mechanism. This is structured so that it's making it as rigorous as possible. It's quite broad, some of the characteristics are like 0 to 20%. So it's drop downs, tick boxes, as much as possible so that we can actually compare data in a more meaningful manner and less subjective in some ways. And so it's at least comparable. As you can see here, you're seeing the sort of broad indicators that are being used. For people who are interested in it, you can actually attach images to different sections. I've just done this as an example for a friend, David Gregory, who's interested in fouling organisms and he's interested in timber infestation in the Baltic. So in this situation, I was showing him the utility of GIRT to help the community to go out and dive and look at teredo worm invasion on wooden vessels and to monitor that and how they could use this platform for that purpose. GIRT members are basically capitalising on new technology, new techniques, and GIRT gives sort of optional priorities for people based on the visibility, bottom time, how much air they've got left, how big the site is. So I try to give people a bit of guidance around what they can do and how they can do it. Effectively, if their site's small enough and they've got enough time and air, they can actually do a full photogrammetry of a site just like this, and then they can add condition photos. I generally recommend up to 10 condition photos of the site. And those condition photos can be attached to that photogrammetry to show different things. So we're talking about qualitative and quantitative data collected through those 59 variables, supported by scale photos, scale video, and 3D photogrammetry, which is scalable, of course. That information then is attached to the records showing where people have adopted their sites, and you can actually access the report. Now you can see there the colour difference on the Rainbow Warrior site is yellow, because when we did the survey of the Rainbow Warrior, we were able to assess the corrosion rate, what the implications were. So the threat to the site was indicated by that colour change. So not only does GIRT collect and make publicly accessible the data, it also is showing people the interpretation by the citizen scientists of what the condition and what the threat to the condition of the site is. And that is moderated through the process in the GIRT workflow. Now here, one of the things too, because of the large volume of images and using photogrammetry, GIRT is actually very grateful to Sketchfab, and we have a GIRT website there, and we're able to get members to upload their 3D models into the GIRT website, which we can then use and also put that link into the GIRT survey reporting form. Once in the website, we can also then attach archival images, we can attach the actual condition photos, and we can effectively give people a tour of the site so everyone can come back and repeat the same survey in the same depth, facing the same way, doing the same thing at the same time. So it's a very strong system. So here you're seeing the place where the explosion happened. Here's the archival photos of where that explosion was on the Rainbow Warrior. So it's a very good interpretive tool. Here is an example of a site that was modified, that was adopted by two people, one being a young daughter, and the young daughter did this beautiful photogrammetry first go and created this lovely model. So GIRT is a very teachable process and very empowering for anyone going forward. An example of the utility of GIRT for science-based decision-making around change is here was the first time where anyone's ever managed to get a good site plan out of the Gothenburg site. Not only obviously a good site plan, but we've got a complete 3D model. So that's absolutely excellent. As I mentioned to you, the allocation of threat and risk is just following the standard risk assessment process, identifying the likelihood of threat, and then the consequence and giving that assessment. Once that survey information is in the system, people can download it, look at it online, or download a PDF version of it. So where are we now with GIRT? We've actually got GIRT members in 10 countries around the world, which is really thrilling. I hope to have a lot more in the near future. I've had a few IT issues, so that's certainly slowed down. And COVID did some wicked stuff to us too. But in the interval, if you're interested, please come contact me. Happy to talk to anyone about joining GIRT or just even about the science behind it. So I look forward to working with people and to hearing the rest of the talks. Thank you for having me.